This right here is a paper display, also known as e-ink. It's a high resolution, high quality display that looks like paper. And it cost me 3 times more than this TFT display we've reviewed previously. So in this video, I will show you how it works, how to control it with code. If you enjoyed this type of content and want to see more reviews, please do like the video, subscribe to the channel, let me know in the comments what you want me to review next. There's a couple things off the bat that make this expensive e-paper display worth it over other displays we reviewed, like the TFT, the OLED, the LCD character display, and more. The reason is this paper display doesn't work like normal displays. It doesn't have a backlight and then pixels that light up in individual areas and need to constantly be on to shine light to show you an image. Because right now this one's off and you can't see anything even though all the pixels and everything are there. The way that e-paper displays work is we're actually looking at a bunch of fluid, a bunch of liquid here. And we're looking at the top layer, which is currently white. Under this is a clear layer of fluid, and then under the clear layer is a black layer of fluid. Now the white pigments that we're looking at right now are positively charged, the black pigments are negatively charged, and then under all those we have kind of like a base where we can charge certain areas of the display and create a magnetic field and pull or push those colors on different areas of the screen. Now if you do that in enough spots on the screen, you can start to make something that we can see, like text, images, a drawing, a circle, a rectangle, any sorts of stuff like that. If I can choose a very small area and put a little bit of charge there and get the white pigments to go down and the black pigments to go up, we now have a black dot in that area. And if you do it in enough areas, you'll create an image. Now the cool thing about this is it can hold its state for a very long time even when the power's off. So you only need to use power to change what's on the screen, which means it's super low consumption comparing to anything like this TFT display. So I could have it change the image, unplug it from the wall, and now that image is going to be there for, I think it said like up to 6 months or something like that, which is absolutely crazy. One issue with these is the refresh rate is awful, so animations, any sorts of moving things that require you to refresh somewhat fast will not work on these displays. They're really bad for that. So if you want to display numbers that are changing in real time, this might not be the best option for you. But if you want to label something, like these are used right now on doors at offices and lockers. If you want to label your name on there and just keep your name on there for a week or two, these are amazing for stuff like that. I'd say the biggest problem for anybody wondering why these aren't used everywhere in the world, it's because the entry to barrier is the cost, or barrier to entry. One example of these being used in consumer products is the Amazon, I think they're called Kindle books or Kindles. They're the e-books that you read. They're pretty much exactly like this display here, and you see the words and everything on there, and you click next page and it flickers and then goes to the next page. That's what these are. These are the same technology used in those Kindle books. The cool thing is about these is they're actually really simple to code, so let's plug it into the computer and get started. My board is made by Waveshare. It's the 4.2-inch e-paper module. For this, you're going to need to go to the manufacturer's website and find the library and the code that they use for their product. So if yours isn't made by Waveshare, go to whoever made yours and follow their tutorial. This one is mostly for Waveshare products. All right, so I pulled up on my computer here the Waveshare tutorial that they make for Arduinos. If you have an Arduino Uno or a Mega, even if you have the replicas like me, that's the pinout you have to follow. So here is D7, D8, 9, 10, 13, 11, ground, and 5 volt. That's what I have everything plugged into here that I did off screen. Just make sure you have good connections. Make sure that your board is labeled here, and you can, just follow each wire to your Arduino and just make sure it's plugged in correctly. So the tutorial says that you need to download the demo, which has all the code you need to run it over there. So I'm just going to open this up. So once you've unzipped the project right here, e-paper code, go inside to Arduino, and then you can see all the different boards they make, all the sizes and all that. If you look at your board, for me, mine's the 4.2-inch e-paper module, and then it's the version 2. There's a sticker here that says V2. So I'm gonna go and open up the 4-inch V2, which is this one, and then open up the INO file, the Arduino file in there. First off, you have to include the libraries, which they do for you. Uncolored and colored, 0 and 1 is just a nice way of labeling 0 and 1 instead of having 0 and 1 everywhere. Down here in your setup, you're going to have serial begin, and this is the rate you're putting it on. So when you go to serial monitor and tools, and you have to choose, oh well, there's no board selected, but usually you have to choose here a rate, and that's the one you're going to choose. Here you're going to make your EPD variable using the library, the EPD library. And then down here, it checks if it works. So epd.init, it's just like a starting function. And if it's equal to 0, there's an issue, and epaper init failed. And then it's just going to exit you out the program. Here, it clears the display from anything that could be on it currently, which is important to do, because if you don't do this, it's going to start writing over what's already there. One thing to note is this program is extremely heavy for an Uno. Like, I've maxed out my Uno already. So I'm just going to delete a bunch of stuff that we don't need. Let's run the demo to see what it is. It looks like the first thing it does is clear the screen. It draws a text or a string at 00 ePaper demo at font 24, so the biggest font I guess that they offer, and then colored. One thing that's cool about these, but also extremely tedious, is there isn't actually like a font library. It's just someone who at Waveshare or whatever sat there and literally hand drew the pixels for every single symbol. So if you go down here, if you want the letter F, I mean, here's what it looks like. But if you go and you add a couple dots here, the F won't look like this anymore. It might look like, you know, something else. You might add a couple pixels here, and every time you make an F, it's going to look like that on the screen. And now we should be able to upload it. Let's go into our serial monitor and just choose the right rate. Where is it? This one? Oh, look at that. So I guess the whole background is black. Now it's sweeping. What is it doing? It's clearing the screen over and over. Look at that. So we have black font on white background. We have white font on red background. We have a rectangle with 2 lines, a circle, a filled red rectangle, and a filled red circle. Now, what happens, let's say you want to do something where you don't have all this stuff, you just want to make your own. You could just go in here and copy paste some of these lines, make it whatever you'd like. So let's do this. Let's just write the word subscribe. We'll do font 24 because it's the biggest one, colored, and then set partial window black. Okay, let's try that. So it should get rid of all the shapes, all the colors, everything. And we'll just see subscribe in the middle. You can see what I mean about the refreshing being awful. It has to go through this process of black and white, clear the screen, and then write what you want. So there we go, there's the word subscribe. It's kind of off screen, kind of screw that up. I should push the cursor where it starts. I should put it back here. But either way, let's do the final test here. Let's take this and let's just unplug it. It's kind of tight on there. Now check that out. You can see there's no magic tricks, there's no battery on here. I mean, look at that. It's just as clear when it was plugged in. If I did it with one of these, if I unplugged it, it would just instantly die. So one thing that you could do that'd be pretty cool is, for example, let's say you had some sort of moving object like a textbook for school, or I don't know, something like that, and you just wanted some notes, whatever. You can build yourself like a 3D printed case and put it on. Plug this in, change the text, unplug it, and now it'll stay like that for however long you need. Kind of like reusable post-its. Maybe that's something we can do in a future video. We could just get like 5-6 of these and just make post-its and put them on the wall and then take them and reuse them instead of having to scrap the regular post-its. That could be a cool project to do. And then plug it in and click the reset button. There we go. So if you enjoyed this video, please do give the video a like and subscribe to the channel to see more cool stuff like this. If you have anything you'd like for me to review in future videos, put it in the comments and I'll see you in the next one.